We are starting the recording, everyone. Welcome, Workshop 6 Animations. Exciting stuff. We're halfway through, almost halfway through after this one. So
Oh,
it's good to see how fast this is progressing. I see people have been trying to play around with some animations already in Unreal, got some fun results. It's always the case. Um, and me, I'm going to ask you to put your microphone on mute because it sounds like you're in a bit of a basement. There's a lot of extraction going on with some air. There we go. Oof. Oh, almost. So cool. Is he frozen? Is it just me?
What?
Oh, press mute, please, man.
Oh, sure.
There we go. Lovely. Nice and clear. Cool. So last week we've touched on characters. We've imported. Don't know if you can all see my screen. I've started sharing. We've imported our custom character into Unreal. I've chosen Fatboy Slim over here, and we managed to play the character and have him moving around our environment, but obviously without any animations. So he's in T-pose, which is a very crucial step to the avatar creation process, which we covered last week. So yeah, this week we're gonna add some animations to our characters and make them move around in the scene. I don't know if you guys had a chance to download those animations I've shared on Discord. Just a simple idle and a walk cycle, but if you've got some from last week and have been playing around with some, feel free to use them as well. Lovely. So I'm gonna escape out of this, and I've just loaded in my landscape map, as you all should have by now. And I'll bring in my browser here just so you all can see a bit of reference to what I'm talking about. So this is kind of my main area of expertise, I'd say, in Unreal. Certainly not blending and creating code and movement-based structures in Unreal, but certainly the bones, the bare bones, no puns intended, the bare bones of how the animations are constructed and recorded and imported into Unreal. So that I've been doing for 6 years in the UK. Traditionally, what we see here on my screen right now, as we covered briefly last week, is a very basic avatar character skeletal structure. Now, rig is a term we're going to use often in animation, so familiarize yourself with it. So as you can see, this basic rig, which we covered last week, as I said, you can, if you expand this root, you can see all the skeletons, the hips, the legs, the shoulder, clavicles, head bones. So that's usually very universal. When you create characters, they come with certain standards. So in Unreal Engine, there is a much more updated version of animation rigs, which I won't dive too much into detail in this tutorial, but feel free to have a look at it. What we're going to learn here is the basics and the bare, like I said, the structures of animations and rigs, and how to apply simple animations to a character. But if you were to follow the animation route down the line, you would need that basis, that foundation, for understanding how these more complex rigs can be used in Unreal Engine. Unreal Engine 5.5 have released some very, very nice animation logic, per se, which allows you to manipulate assets in your scene based on collisions and stuff like that. So it's really, 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 really cool. They've really progressed this field now. It's not the main tool of Unreal. I would certainly still use traditional tools like Maya and Motion Builder to manipulate some of these animations, because they can handle a lot more logic. That's what they're built for as software. But if you have a basis in Maya and you don't want to go back and forth, you can then apply Unreal Engine's skeleton animations and a skeletal rig, sorry, on top of your animations and take it from there. What else have I got here? Yeah, Unreal have really documented this process as well, their development and sort of what you can achieve with different types of animations. The really complex part in the animation process is the retargeting, and that's another term that you will hear often in animation, is the ability to transfer animation from one skeleton structure, from one character to another, without having to do a lot of manual work on top. So what I mean by that is, let's see if I can pull up this example. So I chose, this is Mixamo again, I chose this character last time, and we'll see this in Unreal when I show you later my test. Is okay, no want to work. Okay, I'll show you in Unreal from a quick test that I've done today, or from my import. Is you can see how my character's hands are in his body. So obviously different characters have different proportions, sizes, I guess, or they might have different types of equipment like belts with ammo around them. So you really have to work with these sort of spacings, and Unreal have done a great job in giving us tools to allow us to manipulate these animations very quickly. So a simple slider bar to adjust the clavicles a little bit, just to bring the arms out a little bit. Now it's somehow compensating for errors in rigs or animations you create, so bear that in mind. It's more of an artistic fix, but it's not like it's not something you would apply, let's say, if you're building like a really AAA game. But companies who create games have mastered this sort of logic to be able to apply all these different animations to different characters. So for instance, that's why Mixamo is so good. Any animation we download, we can apply to every single character. So the rigs are all, the skeletal structures are all the same, so we can download any animation from the library over here, and that will automatically apply to our characters, which is great. So we can download any one of these, apply it on, and it'll give you a good foundation. These are very good base layers, I'd recommend. So you can use this as a base layer for your character animation, and then in Unreal with the rig on the logic, you can apply on top to then manipulate the assets a little bit better. So increase the arm spacing if required, increase the leg spacing, tilt the head in certain directions if you want to make it more artistic. Really, you can go nuts with it. Cool. So I'll show you a little bit of what a animation state looks like in Unreal. So what an animation state is basically the ability to transport your character from different animations and back. So let's say if I click W on my keyboard, I want to execute a walking command, or walk forward, or whatever, walk, stride, whatever. And that walk forward has to transition between my current state. So currently, the best way I can explain it is, if you see here in my viewport, this is my current state at the moment. So this is my T-pose. So I'm gonna go from T-pose to idle, to walk, to run. Maybe throughout the game you will have other trigger animations like shoot. Once you click on the mouse, that will force the gun to go up and walk and shoot. So you can blend different animation states together. So this is slightly a more simple one, but you can go crazy with it and apply lots of logic. Now I do not recommend this because it's very hard to track. I don't know who made this, but you can create lots of different layers of these animation states and also blend between them. So like I said, you can manipulate upper body only, you can manipulate the lower body only, you can blend between upper body and lower body, you can manipulate the full body, there you can we'll play around with it. But we're going to create something very simple today, from idle to walk cycle. Any questions up until now? I know I've rambled on. Skeletal structures. All good. Moving on. Let's get to the nitty gritty. Sweet. So, back into Unreal Engine. Go back to my content browser. Make that a little bit bigger so you can all see. Alright, so first step is to import our animations we've downloaded. So everybody locate the files where you've downloaded them. And in our avatar folder we've previously created, which contains our avatar / character. You don't have this folder right here, but we're going to right click, create new folder, and call it animations. Get nice and organized. Now in our animations folder, we're going to browse to where our animations are downloaded. Just over here, and select both of them if it lets me, and drag and drop them into your content browser. That will bring you a pop-up window, and it will prompt you first off to select the skeleton. Now because we've imported our character last time, we can go and select our character skeleton. You should have a list here from the default Unreal ones, but we're going to go and select our character we've imported last week. Keep everything default for now. If you wanted to, you know, actually certain software might use different coordinate systems. Like we've imported characters last time, they were facing downwards, so bear that in mind. If you're using Maya, you might have to import your animations at a certain rotation, or export them. You can actually export from Maya, maybe your other software, with those rotations in mind for Unreal or translations, etc. But for now, we're going to keep everything default. If you wanted to adjust the frame range that you import, you can change that. You can adjust the frame rate that the animation is recorded at, but we'll leave it as default for now. And we're going to hit import all. Should take a second to load. Few errors come up. Imported bone transforms different from the original. That's all good for now, and we should have our two animations in here. So if we double click on one of them, we can already see it playing back, and here we have the frames and the length of the animation, which is about 300 frames. You can even see it here, 298 frames to be specific, and the frame rate in which it is 30 FPS. Cool. So there he is, little boss man. As we said before, his hands are shrunk into his body, but that's something we can manipulate later on using sequencer or custom animation tools in Unreal. Good practice. We're just gonna get a quick save after we've imported stuff, just in case it crashes. So that's Control Shift S to save all. And we can also click on another one. It's a nice little walk speed. Bit of a rough walk, but that'll be a little bit fun. Are we all there up until now? All good? Got two animations import?
I chose a running animation, but it seems to move the character through space. Is that an issue, or shall I get the walking animation that's in play?
So it's got a different transform.
Yeah, it kind of seems to be moving, like it literally physically moves the character forward in space.
In the so you download your own one. Okay, so quick trick with that is, so what I've done with Mixamo, is if you select the walking animation, it's all down to the root, so you can manipulate it in Unreal, but I won't necessarily show that. Why is my Mixamo not playing ball? There's a checkbox. Once you click on the animation, there's a checkbox in what's the checkbox? In place. There's a walk animation. Yeah. So you see my screen?
In place. Yeah,
In
bro.
place.
Yeah, there we
So
go.
what that will
That's
do?
exactly enough. Well, thanks, man.
What that will do is it will remove the transform. We can redefine that in Unreal, but it's slightly more complex animation course.
No,
let's
that's
say,
awesome. This is
what
perfect.
runs. So in place. So
Thanks,
whoever
man. I
wants
really
to do that in
appreciate
the future should keep that in mind. Also, now that I'm here, is what I wanted to get to earlier, is Mixamo have kindly added this character arm space slider. So it's what I was talking about earlier. You can either do it in Mixamo or you can do it in Unreal, because maybe in Unreal, if you add more logic on top, you might want to see that you might want to space it out even more. So this is a good sort of starting point. But you know, all this kind of logic you can create in Unreal with blueprints as well if you wanted to go down that route. There's a lot of people building tools for animation houses like that. Come on, but what a little walk, what a little stroll, my god, I'm rolling down the street. Let's go. Cool. Of course, a lot of GPU in the background, I'll close that down. Alrighty, so we've got our two animations in here. Now the next bit, I'm sort of gonna we'll prepare it and I'll whiz through the following bit. So first off, we're gonna start by creating our animation state. So how these animations will transform from one to the other. So what we're gonna do is let's create a new folder just to be organized and call it blueprints. So in the avatar folder, we should have animation, blueprints, material, textures, and our 3 assets. So double click in the folder blueprints, right click in your content browser, go to the animations tab and look for blend space. And that's going to prompt you with to select the skeleton, and you're going to select your skeleton of your character and call it locomotion. And once you've done that, just click that and fire it up. Ooh. So you should see your character in a T-pose. T-pose is, oh sorry, I didn't cover that bit. T-pose is quite it's either a T-pose or an A-pose. It's quite a traditional way of rigging a character, because it's more of a unified format that everyone can adopt to. And when we're rigging a character in a T-pose, it's easier to create sort of weight painting around the muscles and the polygons of the mesh to tell it which polygons basically are being manipulated by which bone. So obviously the clavicle bone will have the polygons around that area being affected. If it won't have affecting the areas of the wrist, for example, or the leg, it doesn't make sense. So each specific bone has its own area of effect, and that's why traditionally we rig them and create the skeleton in a T-pose or an A-pose, because it's easy to create those weighted effects, and then we apply animations to test it out. So as we're here in the locomotion blend space, let's give this in the left hand side in the asset details, you have axis settings. What we're going to do is we're going to give a name to this horizontal axis, because we want to move, horizontal, we don't want to move on vertical, and give this name again locomotion, and that will rename this axis base here. And what we're going to do is the maximum value is 100. Let's set this to 500. And what this maximum value is basically going to correspond to our speed later on. So our maximum speed that we're going to cover, maximum velocity moving forward. So currently it's so if we're walking, we're going to reach a speed of 500. If we're running, we can reach a speed of 1000, but currently we're just doing the walk. Those values are not standard. They will change depending on your character's size, how fast their legs are moving in the animation, all that stuff. So just for basic use, we're going to have that. And on the left hand side, we should have access to this asset browser. On the right hand side, sorry, have access to this asset browser with our animations in there. Now I have two versions of both because I have imported two different folders. So what we're going to do is we're going to take our breathing idle animation from the asset browser and drag and drop it under 0 in the left hand side corner and let go. That will automatically assign that animation to our character. Now what we're going to do also is take our walking arm space animation and apply that to the end corner 500. So essentially we're telling it from 0 to 500, that's your blending time. Now we're not going to see the walking animation applied just now. We're going to get into the logic of that in a minute. Cool, so that's it for this part. Blend space is basically start to end what you want to achieve. So if you're going from idle to walk to run to maybe even sprint or fly, then you have the different states laid out here in the horizontal graph. And obviously if they had a vertical axis assigned to it, so if you were walking a straight line and all of a sudden you wanted to walk to the right, you would obviously apply a striding animation, which would allow you to stride to the right or to the left depending on which direction you're going. Cool, so that's it for that. We're going to save that, close that down. We're going to use it in a minute. And what we're also going to do in this blueprint section is right click again, go to animation, and we're going to create an animation blueprint. Our very first blueprint, everyone. Woohoo, exciting. And same as before, we're going to select our specific skeleton, so keeping that consistent throughout. Now you can see why retargeting animations to multiple different characters with the same rigs can save you so much time, because imagine having to recreate all these blend spaces and animation states and animation blueprints for all your separate characters. It's insane. So companies like Disney and all that, even cartoon as you see on TV, they probably all have the same rig, the same logic. Makes sense. So we're going to select our boss here in the specific skeleton and hit create and call that let's give it a basic name, base underscore anim BP. Anim BP, short for animation blueprint. And we're going to fire that up. And as soon as we do, we are prompted with the animation graph. Now, if you don't have the animation graph visible and it's only showing you maybe the event graph, you can, on the left hand side under my blueprint, you have event graph and animation graphs here. You can double click either and that will open this sort of tab here as a browser, so you can flip between the two. Cool, lovely. So in our animation graph, we have what we call our output pose here. So that's going to be our final result, as it says here, which is clearly identified. So I love working with blueprints, so easy. And we're going to drag out of this result, drag and drop out of this pin. And just to repeat that, we're going to drag out of result, out of the graph and let go. And we're going to search for animation state machine. And you're going to click that. Now you can give it a name if you want, locomotion, if you click on it, locomotion state, let's say, locomotion underscore state. And once we've done that, we're going to double click and jump into this locomotion state. Now, Unreal works very linear in the way the blueprints are laid out, so if you ever get lost and can't find your way, always keep an eye out for this top right hand toolbar section where my mouse is highlighting now. So we went from animation graph to the locomotion state, so you can see the linearity there. If you also wanted to move backwards and go back to the skeleton or to the animation and see what's up, you can also move in this pattern here. But also in the animation graph, you can also see our locomotion state, which we have created right here. So easy to find everything under my blueprints. So what we're going to do when we come for you is drag and drop out of this entry state. So again, any pins we want to create, any blueprint logic we want to create out of Unreal, we can drag and drop out of pins, or right click in the viewport, and we want to add state. And we're going to call this again, as you all know, locomotion, keeping it consistent so we don't get lost. Now in here is where we can apply again. We're going to go deep down into layers, but you can reverse these layers and apply more logic to the animation. So rather than creating this chaotic structure of a blueprint, we can break this down into multiple and like these, and define them later in our event graph. Cool. So inside locomotion, we're going to double click again and go into our locomotion state. And what we're going to do here is drag out of our browser. So you might have this enabled, animation preview editor. You also have asset browser visible here. And this is just a nice way for you to only use the assets that are feasible within this blueprint. So we'll segment it for you. So we're going to take our blend space, which we've created. So this is where we're going to apply our blend space. And drag and drop your locomotion blend space and drop it into the graph. And connect it to the output animation pose. Cool. So we're going to leave that there for now because we need to take some. This is why Unreal is good. It creates a lot of templates for us to use and a lot of assets we can reuse. So if we want to focus primarily on animation and we don't want to get into the details of blueprints and characters and their functionality, then we can take those templates, apply them to ours, and then just work with our working animations on top of that. So what I'm going to do now is go back to my content browser, and in my content browser I'm going to navigate to the folder called third person blueprints and third person blueprint. Or another way to navigate to it is in your outliner. You have it in your level as well. If you want, you can edit blueprint here, and that will take you to a which we seen last week. Very it's not too complex to understand, but we'll cover it in, I think, next or the following tutorial and what all this is. But what we are focused on at the moment is what we're focusing on at the moment is, at the moment here on the right hand side, you have this animation class called ABP Cube Sync. Now this animation class is what is the animation blueprint we've just created. So we need to assign that animation blueprint to this character. Currently it's got the one based off of the default mannequin we had in there previous week before we applied our character. So before we change our one to our character's one, we're going to click this browse to asset folder icon next to it, and that's going to take us to the animation blueprint folder, so we know exactly which one it's using. It's a nice way to organize, find assets and where they are. Now this animation blueprint is a child of ABP Money, so just to avoid, if I double click this, you'll see this is a child ABP, so it just uses the logic of that. So if you wanted to reuse the logic you created for one animation blueprint to another, you follow this further, more advanced tutorial. But I'm going to close that down, and I'm just going to open up ABP Money blueprint, which is the parent. And as soon as I fire that up, we are presented with our event graph, and in here under the animation graph we have the locomotion states of this character and how it was created. So feel free to open this up and study it a little bit more and create more advanced blend spaces in the future if you like. Feel free to, but we're just going to use this as reference at the moment. And I'm going to go back to my event graph. Guess what we're going to do? We love a good copy paste. So we're going to reuse all this code because we don't want to create it from scratch. We're going to reuse all this logic that has been created for us. And what this logic does at the end of the day is communicates with our character blueprint and tells it, you know, when I press W, when I press E, when I press spacebar, when I press left click to shoot, what is happening, what animations are being triggered. So this is exactly what this logic does. So what we're going to do is we're going to click and highlight all of it, and Control C, and we're going to go back into our base and MVP and go into our event graph, delete what's already in there, delete what's in the graph, and Control V to paste it. Now this will not work straight away because it is using certain variables that are defined. If I look here in my animation blueprint, we can see there's some variables here that are defined in order for this logic to work. Now if I go back to my base animation blueprint, under variables I have no such variables. So when we copy and paste this code, we have to essentially recreate those variables. Now it's very simple to do. You can custom press plus and start inserting them in with the same names, or the nice and easy way to do it is to right click, let's say on set here, which is character variable, right click on it and create variable. So what that's done is under variables now it's created a variable called character and is of type variable type character. I won't deep dive into variables at the moment. We'll talk about them a little bit more in the next session, but they're essentially the, again, bones in which drives our logic and our code in Unreal. So anything that's grayed out, we're essentially going to create variables. So this movement component also requires a variable. So we're going to right click on set movement component and create variable movement component. Moving down the ladder, we're going to right click on, nope, that's already created. That's our character one variable. Velocity is another variable we need to create, so that's how fast we're moving. So right click on set velocity and create variable, and those should start turning like opaque in their own colors, so yellow is a vector color. Ground speed is another variable that we're going to use, so right click on set ground speed, create variable. And two more we gotta do is should move, right click, create variable should move, and is falling, right click, create variable is falling. Now is falling we're not using because we don't have an animation, a falling animation, so it's not going to trigger that, but there is some backend logic that requires us to set it before we can compile it, otherwise it's going to crash. And just to break this down in very simple terms, what's happening in here is every time this animation blueprint gets called, it's going to do a sequence of three things. First, it's going to set the velocity, and it's going to set it to the ground speed, and then we're calling that ground speed, and we're defining the acceleration, in which the direction in which the character is moving. And here we're creating an if statement to say that if the character is not moving, what is it doing? And in this case, it might be falling or it might be standing still. So we'll deep dive maybe more on this into the next tutorial, but feel free to also have a look at some of these variables and some of these functions and what they do. I'm sure some of our coders here are very eager to break this apart. For those who are more interested, I believe if you double click on one of these variables or right click somehow, some way, I think double clicking, I'm not going to do it right now, it will launch Visual Studio. Or if you double click on a function, it will launch Visual Studio, and you can see all the code behind what this blueprint function does. It's got a nice little F on it. Cool, so now that we've set all those functions, we've got all those variables there, we can compare it to our blueprint that we've copied them from. But also, if we hit compile, we can also see whether we get this nice checkbox or whether we get any errors. So for instance, if I was to delete this falling for now, just to give you an idea. No. Okay, it's just a set. I'll redo that. If I was to delete that for now and hit no, it's not going to work. But yeah, it will give you a nice error if you haven't copied them, if you haven't created those variables, and it will tell you it needs that to proceed, otherwise it won't work. But as soon as you hit compile, we should already see our character now in our base idle animation, our breathing state. Heavy breathing he's been doing. So what we need to do next is basically apply this ground speed variable component into our locomotion state so that it matches, and that's the speed in which is defined, I'll show you in a second, in the animation blueprint. So back into our locomotion state, so that's the one which contains our blend space. So again, going down the layers, animation graph, locomotion state, and then the actual state itself, what is it doing. And what we're going to do is take out of ground speed, drag and drop the float of our variable ground speed, and set it to locomotion, and drag and drop it on top. And basically we're saying our ground speed equals to this locomotion variable, so that will dictate the speed in which the character is moving. Now this ground speed is not defined here, is defined in the blueprint animation. So if I go back to my blueprint third person character, and I search here in the details, I think speed, yep, under character, movement, walking, you've got the max speed set to 500 centimeters per second. Pretty fast. So yeah, here is, you can reduce that, but as long as you reduce that, that has to match what you've defined it here in the locomotion state, so in this blend space. So in the blend space before, I'll bring that back up 1 second so you can see avatar animation, blueprints, locomotion blend state. We've defined this from 0 to 500. So that's 0 to 500. That also needs to match, the max needs to match what you've set here in your current walk speed. Lovely. So we all happy till there? We've got this connected. It sort of looks something like this. We hit compile and save. We've got our idle state. We've got our ground speed connected to our locomotion. That's connected to our entry state. And then that's connected to our output pose. We all groovy there? Any questions?
Yeah, all good.
Sweet. Lovely. So we've compiled it, we saved that. We have set up our animation blueprint, which contains an event graph with the logic from our base character animation blueprint, and the state machine basically that drives the animations in our proposal. So what we're going to do next is go into our third person character blueprint. I'll remove this search filter, and in here in the animation class we can select this drop down and find base animation blueprint which we created, and click that, and as soon as you click that it should automatically apply. So under the details section in the animation, use animation blueprint and define it by an animation class. Now if you wanted to, for whatever reason, you don't have to follow this step, but if you wanted to for a reason, you can actually just use an animation asset. So if you want to use this character for other reasons, let's say just in the level, just playing some animations, you can use animation asset, select an asset, and you can use it that way, looping, playing, initial position, etc. So you can actually assign an animation by default there as well if you really wanted to, and then you can just drag and drop that into the level. But this is a character that will play, so this is not the right logic to go about it. I'm just going to reset that. And animation, so we should all have something looking like this at the moment. Lovely. And what we're going to do again is compile and save, just to make sure we don't have any errors. And now if we go back to our map, our level, and we hit play, fingers crossed, and press W. Whoa, yeah, F11. Yeah, right. My man. Oh, you can even jump, but you're not running. Now let's say if we wanted to set up a sprint animation and map it to like shift, that way, so when you walk press W and you press shift, then it will sort of sprint, and that's another way you can add to the blend space logic and make that slightly more complex. Oh, but this is satisfying as it is. Let's see how many 360s I can do. Ooh, oh, yeah, that's a 720. One more. 120. Cool. So we all satisfied with that? Obviously it doesn't look great, but character stops when you stop pressing W, initializes, and this is the kind of stuff you can play with in the blend space, right? When I'm pressing, just pressing W non-stop, you can see that little sort of glitch as it's trying to transition. But what's beautiful with this blend space is as the animation, so as you can see his breathing animation is moving, is shifting his body left and right. As I press W, that doesn't change. So he's moving forward, but he's still maintaining that shift left and right with his breathing. And that's, you know, stuff that you can play with in animation, in the logic, how that smoothness happens, how the transition happens, or what happens if it's going backwards, how is he stopping, you know. Now he's stopping and he's sliding. You know, that's not realistic. So we want it basically, as soon as I let go, we want it to just be an immediate sort of, I hit a wall, I hit a brick wall and I'm stopping straight away. So not to take an extra stride. But this is all more complex animation footwork stuff that you can get into if you're interested. I can share some links. Cool. Faster than I expected and more smooth than I expected. Lovely. I've learnt this about 15 minutes before the tutorial, so before the workshop. So that's hey.
The running animation actually ended up looking way more natural.
Wait, what?
This what was it? I'll put it in the chat. This running one actually ended up looking way more natural. I'll put it in the chat for you guys.
You can share a screen if you want, man. You can share your screen. Well, that's sort of the bare bones of that workshop, I guess. So we can now take questions or do some more. We'll talk a bit more about animations in Unreal. Let's watch Milo stream and see what he's got. Whoa, look at that, boy. Look at that. Sick. Nice one. Sweet. Hey man, that's looking good. That's with the same blend space, right? It's with the same method we created now. You're on mute. You're chatting. Looking dope, bro. Looking dope. We'll share some videos of that. We'd love to see what you guys created. It's like moonwalking when you hit spacebar and you jump. It's like moonwalking. Yeah, so that sort of stuff you can add into the logic as well. You know, stop hovering feet in the air when down. I'm just doing that jumping animation. So that's a way to apply animations in your player characters. Now, if you're using animation, if you're using Unreal for animation for cinematic pieces and not for character movement or games per se, it's a slightly different approach. We don't need to create animation blueprints. We don't have to create logic. We might have to create a blend space or two just to help us transition. Actually, no, not even that. That's more for games again. So I'll show you quickly and briefly how to create animations for cinematic pieces. Let's say you're bringing in not necessarily only character animations, but let's say you're bringing in static mesh objects and you want to fly them around the scene, or you've got some simulation going on, you want to import that, you can do that. Also, if you want to apply Unreal Engine's rig logic, you have to use this method as well. So this method will allow you to create animations and bake animations, which you can then use in the animation blueprints, if that makes sense. So it allows you, it's basically another platform, another animation platform that allows you to create and import, basically like Mixamo, but it's got its own logic. So in the animations folder, again, you feel free to follow, but maybe I can just show you this step. It's a bit more speedy. I can go into cinematics and create a level sequence and call this just animation underscore SQ sequence, and double click that. Now this is basically essentially just like any other animation software. It's got a basic timeline, it's got your frames that you can use depending on your outputs, and it's got an animation graph. So here we filter all your keyframes when you're creating animations. And what I can do here is, let's say, find my character in the level. So let's say this character here who I just have in the level, let's say he's an NPC. Let's say it's just a character in the background. Obviously NPCs, you still do them with animation states, but let's say there's an NPC in the background. I've got a track, actor, select the current actor I've selected, and in here I'm automatically triggered with an animation section. If it's not doesn't appear, you can select on the boss or your character and add any one of these audio, events, rig, path, transform, whatever. But what I'm going to do here is click the plus on animation and just select the breathing idle. And what that will do is if I play that, that will automatically just play that animation in there. I can play that and see that. That's a quick way to also clarify, if our animations work nicely. Then I can also, so what Milo did earlier when he imported the animation into Unreal without selecting the in place, what you can do is, let's say now I'll swap this out for, oh no, actually let me do this. Control scroll to zoom out. I'll make this shorter. And what I'll do is I'll add, I'll add another animation here and give that spaced. So that's created a separate layer for this animation. I can manipulate them separately. and adjust the weight in between them. So what it's doing here is going from idle, snapping to arm space, but arm space is still in place. So what I can do here is, let's say on keyframe 80, I can oh no, sorry, let's say right when this animation starts. So in keyframe 75, I'm gonna add a key to my location, and then on key 80, I'm gonna add another key just to maintain it. So that's gonna maintain it. And now let's say at the end of this animation, how fast is he walking? I want him to do 3 or 4 strides before he reaches that time. So he's walking about 50, 60 frames. So I'm gonna select this transform, which direction, Y, moving forward. And because I have auto key on, that will automatically snap and make a key for me as well. Or I can click S on my keyboard to create that key. So now what's happening is he's still there idle. I'm going to play that back, and now boom, he's walking. Now a bit snappy, maybe let's extend this so slightly bigger. I can loop this. So as he's there, he's now getting a few strides forward. So that's just a quick and easy way we can create our own animations in Unreal using Sequencer as well. Now again, that blend is a bit snappy, but I think I can actually, can I do that? Yeah, I can do that. There we go, allows me to blend a little bit better. Way, there we go, yes my man. And if we wanted to extend this and maybe go back to idle at the end, I can copy the animation. I'll add the idle again so that whenever he's there he stops or whatever. You can play around it. Maybe he at this point he wants to shuffle a little bit, and then at that point, next keyframe, he wants to go there. And you can also select these keys and manipulate them again, so you can change that curvature as well. And if I wanted to see these keys in more detail, I can select sequencer curve, select my x-axis, and see what's happening in the transform. Y-axis, Z-axis, I can look at them all at the same time, see what's happening. Yes, boss man. What a cool walk. Wish I walked like that. Cool. So it's just a simple overview of Sequencer as well and how we can add our custom animations. These sequences can be quite complex. So what you can do is create, you can create a sequencer out of this, and now I can create another cinematic level sequence, call it master, and inside my master I can bring in shot track, which is my animation sequence. So now I can play that back, but it's now broken down a little bit more. So now if I want to create a massive shot or a short film, I'm creating my new film, and I have multiple different sequences, one for cameras, one for animations for objects, one for animations for characters. It's a nice way to line it all up, and it doesn't look messy, because as you can imagine, if I have lots of different characters in here and I'm animating them all, it can get quite complex, and actually it's nice and easy for you to work in your viewer. This sequencer tab usually I have on a separate window, on a separate screen, full scale, because you want to see the graphs, you want to get zooming into detail here what's happening. So I suggest you run this on a separate monitor, not in this small window of Unreal. But yeah, any questions on Sequencer and how we can use that in the future?
No, man. I used it before, so it's nice to see it again. Get used to it one more time. It's good.
Yeah, in here you can get quite, like, I don't know if this will work, but then you can start, these are the rig concepts, so you can start applying your own custom rigs. It's not, I tried, it's not gonna probably work, but it's a bit more complex.
Got that bones, bro.
Just for context, what these rigs help you to do, I guess I didn't really mention that before, which is my bad, is it's in animation. We have a concept called forward and inverse kinematics, and what these rigs do, it allows you to, rather than before in animation, you used to be able to, if I rotate my elbow, if I rotate my shoulder, it's gonna take my elbow and my wrist bones with it as well, right? So just natural movement, that's what it's gonna do. What we can do with these control rigs is, let's say we know that logic, so we know shoulder is connected to elbow, elbow is connected to wrist. So what I can do is I can create a control point around my wrist, and wherever I move my wrist, my elbow and shoulder should follow as well. So that way we can create more easier organic animations and less robotic movement. Rather than manipulating every single bone on its own, it can become quite robotic. You might want that in your animations if you are designing robots, but control rigs as such, and inverse kinematics and forward kinematics allows you to manipulate the whole body as well, and allows you to apply logic to your skeletal structures, so things perform smoothly. So even if you have, characters who are rigged differently, or you've got tails and weapons, you don't want that intersecting with the body, or when he's moving, you want that to flow naturally. So a dinosaur's tail won't move without him moving his waist, so his waist sort of movement is all interconnected with the tail. So it helps us create, like I said, more organic animations, and much easier. We will keyframe, we start keyframing the rigs rather than keyframing the bones themselves, and that really is, as Unreal evolves, these rigs get more complex and more complex, but they allow you to do so many different things. We're using it on a very basic level now, but you can imagine on cartoons where characters squash or compress or explode, or whatever you've seen in the past in cartoon films. All these are based around complex rigs. And the rigs, this is what I wanted to get to before, is the skeletal structure. So this thing is consistent throughout all the characters, so it's all the same. So when we create animations, we create them with the same skeletal structure, so we can apply them to lots of different characters, but the rigs will be separate for each character. So the control points here. So as you can see, this character has a lot more than this character. This character needs to adjust its wings and flap. So we have different control points, and how the forward, kinematics will respond, and the different limitations, restrictions this rig has. So for a bat, he can't rotate completely like we humans do. You can only rotate, I guess, in a certain axis. So this is what this rig logic adds, a layer of restrictions, let's say, and collisions and all sorts of other logic that help form our animation. Hope that was a good breakdown of it, not too complicated, but we can touch on some more advanced stuff in the future if you guys are interested. And on that note, I'm gonna stop the screen recording. Thank you, everybody.